This is multiplying matrices by scalars. We're at 13.4a. I have 8 previous videos that are linked in the description to help you if you need it. So there's two kinds of products involving matrices. And first we define a product of a matrix and a number. And the scalar product of a real number k, called a scalar, and matrix A. Remember, all the matrices have a capital letter of the alphabet that labels them. So a matrix A is the matrix, and it'll be named Ka. We get it by multiplying each number in A by that number K. All right, whatever K is. And scalar is just a fancy word for number. When we talk about matrix multiplication in algebra, we use the word scalar to contrast a number with a matrix, which has dimension. And a scalar has no dimension, so we can use it the same way throughout the matrix. Scalar multiplication of a matrix means that we multiply every element in the matrix by the number k. And each element is a multiple of k. I got a little arrow going off to the side. I'll explain that in a second. And not every pair of matrices can be multiplied. Matrix multiplication is not commutative. A and B and A aren't necessarily equal. Depends on their dimensions. And the second type of product is the product of two matrices. So we've got one where we're going to multiply a matrix times a number, and then we've got another type of multiplication where we multiply a matrix times a matrix. All right? So here's scalar product. We've got a 3 out here. That's our value for k. Here's our matrix A. And when we multiply this 3 to every single element in A, we're going to get a brand new matrix, Ka. 3 times negative 3 is a negative 9. 3 times 0 is 0. 3 times 4 is 12. 3 times 5 is 15. See how they correlate like that? Let's try it with this one. We have a negative half. Negative half times a negative 3 is going to be a positive 3 halves. Negative half times 0 is a 0. Negative half times 4 is a negative 2. Negative half times 5 is a negative 5 halves. Now, each element is a multiple of k. So, k is a 5 here, right? When we multiply this 5 to every single element of this matrix A, look what we get. Every single one of these elements is a multiple of 5. It's a multiple of the k. See? 5, negative 10, 5, 20, 5, 5, negative. They're all multiples of this 5. See? So each element is a multiple of k. All right? So let's try the product of two matrices. Now, we're going to consider this system of 3 equations, and we've got 3 matrices right here. Okay? So I want you to look at this very carefully. Here's our 3 equations, and this matches. We've got a 3, a 2, and a negative 2. We've got a 2, a negative 1, and a 5. We've got a negative 1, a 1, and a 4. And if you look over here, we have a 4, 3, 7, and that's the 4, 3, 7. All this matrix is this system without its variables. If we had a matrix of variables of x, y, z, and we multiplied every single one of these first equation elements with the x, and then with the y, and then with the z, we would get these for an answer. We'd multiply the 2 to the x, the negative 1 to the y, the 5 to the z, the negative 1 to the x, the 1 to the y, the 4 to the z. They'd each take turns, and we would end up with this matrix, see? So they're really equal if the corresponding elements are equal. So this A times this x is going to equal the B, and they're equivalent to our original system of 3 equations. See? It's just, this matrix is just this without the variables. The variables are right here, and here's the answer, see? Now to multiply 2 matrices, the number of columns in the first matrix, 1, 2, 3 columns, must be equal to the number of rows in the second matrix, 1, 2, 3. See? This means that a matrix with 3 rows and 6 columns can be multiplied to a matrix with 6 rows and 5 columns. So those columns match those rows. So look at it this way. If we multiply a 2 by 3 matrix, it's got 2 rows and 3 columns. By a 3 by 7 matrix, we'll get a 2 by 7. See? Because that 3 and that 3 are like this. That's the columns, that's the rows. We can combine them and get a 2 by 7. See? But it has to be in that order. This 6 columns has to match that 6 rows. See? If it was a 3 by 2 and a 3 by 7, it wouldn't work because the 2 by 3 would work, but not 3 by 2. See, it's not commutative, all right? So, this is going to look really difficult when you first look at it, but after you stare at it for a little while, it's going to make sense. We're going to take this 3, and we're going to multiply it to the 1. Then we're going to take this 1, and we're going to multiply it to the 2. Then we're going to take this negative 1 and multiply it to that 1. We're going to write it along here on our first row, right here. When we do the addition, we're going to get a 4. Then, what we're going to do is, we're going to take every red one and multiply it to a pink one. So we're going to take this 1 and multiply it to that first 1. We're going to take the second 2 and multiply it to this 2. We're going to take that 2 and multiply it to that 1. So see how it goes, the first one to the first one, the second one to the second one, the third one to the third one, like that. And then we add them together, we add the products together, and we're going to get a 7. Then we do the same thing with the green row to the pink row. The first one to the first one, the second one to the second one, the third one to the third one. We add up their products, we're going to get a 4. We do the first purple to the first pink, the second purple to the second pink. See? The third one to the third one, we add them and we get an 8. So what we did was we multiply each blue by each pink, and then we add their products to get the new blue. So we got a new blue, see? Then we multiply each red to the pinks. Then we multiply the greens to the pinks and the purples to the pinks, and we add them up, okay? See? Now we've multiplied a multiple column matrix by a 1 column matrix. To multiply matrices that have more than 1 column, we just multiply each row of the first matrix by each column of the second matrix separately. So we do the same thing we did with this one, where we were multiplying this one to this one. They each take turns going to each one. Except now we just do it twice, okay? The product matrix will have as many columns as the second matrix. So here's our second matrix, B. We know our answer is going to have this many columns. Okay? What we do is we take the 3 and multiply it to the 1. We take the 1 and multiply it to the 2. We take the negative 1 and multiply it to the 1. Okay? And then we do the same thing with these. We take the 1, multiply it to the 1. We take the 2, multiply it to the 2. Take the 2, multiply it to the 1. We take the first one, multiply it to the first one. We take the second one, multiply it to the second one. We take the third one, multiply it to the third one. In the first column. Again, we take the first one and multiply it to the first one to the second one to the second one, the third one to the third one, and we add them up. We find their products and we add them up, and that's just the first column. Now we have to do this to the second column. So each row in this matrix A has to be multiplied to that number in the second column of B. So this 3 is going to be multiplied to the 0, then the negative 1 to the 1, the 1 to the 1, and the negative 1 to the 3, see? Then the 1 to the 0, the 2 to the 1, the 2 to the 3. Almost as if this column wasn't even here, see? Then what we do is, we can leave a space here, just like there's a space between here, and there's a space between here, between the columns. We can leave a space here for our math to show that this is the first column and this is the second column. We add these all up and we get a 4. We add these all up, we get a 7. We add these all up, get a 4. We add these all up, get an 8. We do the same thing for the second group, for the second column. We add these all up, get a negative 2. These give us an 8, these give us a 15, and these give us a 7. that's our new matrix. That's our product matrix. All right? I know this can seem really confusing. If you have to, watch it a second time. All right? Once you get it, it's going to seem so simple. All right? So here's our theorem. The product of an M times an M by N matrix and an N by P matrix is an M by P. So because the N's are next to each other, sort of like this 2 times 3 and 3 times 7, see how the 3's are in the center? Right next to each other? That means we can do it. And that means we're going to create a new matrix, which is the outside ones, the 2 and the 7, the 2 by 7, see? Now take a look at these two matrices. We can't add or subtract A and B because the dimensions aren't the same. We learned that a few videos ago. In order to add or subtract them, they need to have the same dimensions, don't they? But we can multiply A times B because A has 3 columns and B has 3 rows. But we can't multiply it the other way around. See, we can do A times B, but we can't do B times A, because B has 3 columns and this only has 2 rows. It won't work, all right? I'll explain some more, hold on. Now, because we can multiply the A times B but not the B times A, we realize the matrix multiplication is not commutative, all right? So take a look at these. Here's a 2 by 3, 2 rows, 3 columns. Here's a 3 by 3, 3 rows, 3 columns. The first one is the row, the second one is the columns. This is a 2 by 2, 2 rows, 2 columns. 1, 2 rows, 2 columns, all right? We can multiply AB because it's a 2 by 3 and a 3 by 3, and these 3's are right next to each other like this, see? We can also multiply CA in that order, C and then A, because we have the 2 and the 2 next to each other like this, see? We cannot multiply AC because that's a 2 by 3 and that's a 2 by 2, and we don't have 2's next to each other or 3's next to each other like we did in the center here, so it's undefined. We can't do it, all right? Now does it make sense? Okay. So, our next video, we're going to multiply matrices by scalars, and then we're going to add or subtract. So what we're going to do is, we're going to do 5 times this matrix, and then maybe 3 times another matrix, and then we're going to add or subtract and see what we get, okay? All right. I'm going to have a link to the 8 previous videos for this chapter. I'm going to add this to the Algebra 2 playlist. If you've missed some videos, you might become lost or confused. So just remember, in the description, I've got all the previous videos linked there, so you can just hop back real quick for a few minutes and figure out where you got lost and then head forward again. Okay? All right. I'll see you next video. Bye.